Hello everyone, today's lesson is about how to find the domain of rational functions involving a radical. As a starter of the lesson, let's think of how to find the domain of these functions. So the first function is a polynomial function, and a polynomial function has a domain of all real numbers, which means it is defined everywhere, and we can write all real numbers as this R, representing the set of all real numbers, or negative infinity to positive infinity using interval notation. For a rational function, we need to consider all real numbers except the zeros of the denominator. So if I take the denominator x plus 2, solve it equal to 0, I will get x equal negative 2. So this is the value that I should exclude. So it should be not equal to negative 2. To write it as interval notation, so if I quickly represent on the number line, here's the negative 2, not equal. This is the positive infinity, this is the negative infinity. So everywhere to the left of negative 2 and everywhere to the right of negative 2. So I can represent it by writing negative infinity to positive infinity. It's negative infinity to negative 2, union negative 2 to positive infinity. The last function here is a radical function, and we have said before that the domain of radical function is where 3 plus x, whatever under the square root, has to be greater than or equal 0. And this is a linear inequality that can be solved by shifting 3 to the other side. So x greater than or equal negative 3. If you want to write it in interval notation, so starting from negative 3, closed bracket, because I have an equal sign, going to infinity. Amazing. So that was a quick review how to find the domain of a polynomial function, a rational function, and a radical function. Now look at this example, and you may pause the video and think of what could be the domain of this function. This is a rational function having a radical in the denominator. Okay, I'm assuming that you have paused the video. Now, for a rational function, my denominator cannot be equal to 0. So that's square root x squared minus 9 cannot be equal to 0. And as a radical function on its own, the radical function should have x squared minus 9 greater than or equal to 0. I have to find something common between these two. Again, in the rational function, for the numerator, it doesn't matter, like it can be anything, but for the denominator, it can be anything but not equal to 0. And for the radical, it can be only greater than or equal to 0. So if I can exclude the equal sign with 0, then I will get the domain of this rational function greater than 0. So whenever I have a radical in the denominator, then I just exclude the 0. So it's not equal to 0, just greater than 0. This is a quadratic trinomial that we have tried solving it before in a solving domain of radical function. So I need to find the zeros of this quadratic expression, which is in this case equal to positive and negative 3. And representing on the number line negative infinity, positive infinity, negative 3, there is no equal sign here for the inequality, so I will not consider the that circle shaded. It has to be open. Now I have 3 intervals to be testing, so negative 4, 0, and 4, and I'm going to test in this inequality. So it has to be greater than 0. So if I substitute negative 4 to the power of 2 minus 9, I will get 16 minus 9, which is 7, greater than 0, so this is correct. If I substitute 0 squared minus 9, I will get negative 9 less than 0, so this is wrong, or not part of the domain. And similarly for 4, I will get 7 greater than 0, so that's correct. So my domain in this case is the first interval from negative infinity until negative 3. So from negative infinity to negative 3, and open brackets, because there is no equal here, it cannot be equal to 0. If I consider the negative 3 and put a close bracket, this means that the inequality can be 0, and therefore the denominator will be 0, and this is not considered here. And the other interval from 3 till positive infinity, and this is my domain. Now you have 2 questions to try on your own before I show you the solution, so please pause the video and go ahead. Okay, so for now I will solve and show you. So if I start with the second one here, and if you look at the denominator, you have a square root, where under the square root I have a linear expression. So if I just take this 4a minus 1 and set it greater than 0, remember we have removed the equal sign because the radical or the root is under in the fraction, in the denominator of the rational function. Just solving this very simple, very easy linear inequality. So 4a greater than 1 divided by 4, and a is greater than quarter. And we can write this as 1/4 to the positive infinity, open interval. This is my domain. Here, this is a quadratic inequality under the square root. So x squared minus 16 greater than 0. I remove the equal sign. If I get the zeros of this, I will get x squared equals 16 square root. So x equals positive and negative 4. And sketching this on a number line to help me quickly test. So negative 4, open circle, positive 4, open circle. Testing values negative 5, 0, positive 5. And I test in this inequality. So if I substitute negative 5 to the power of 2 minus 16, I will get 25 minus 16, which is 9 greater than 0. So this interval is correct. 0 squared minus 16 gives negative 16 less than 0, not part of the domain. And 5 is similar to negative 5 will give me positive 9 greater than 0, and this is what we are looking for. So the domain is equal to negative infinity until negative 4. This is my first interval, and my second interval is 4 till positive infinity for this part. So you can check your work now, and if everything is clear, you can go ahead and solve the next questions for practice. And if something wrong, you may go back and watch the explanation of the example and try to solve these again. So here you have more questions to solve for practice. And in this question for critical thinking and reasoning, so there is an error here in this question for the steps solved, and you need to find out what is the error and explain why it is wrong, and maybe you can write the correct answer. Thank you, and see you in the next lesson.